So now I'll be showing you how to use the FBX Exporter, and I will use a Sketchfab example for this. This is a good example. I've used it for a bunch of tutorials, and it's good because it's a very advanced example. You have a hierarchy of objects with empties and a lot of crap. And to export this, you'll have to do a bit of pre-processing, and you can use the scene tool organizer for that. So let's disable the stats. We're not there yet. So let's clean this up. So the origins are all over the place. We want them to be on the floor so that if you're a level designer, it's easy to place them down. And we want to combine these into one asset per furniture piece. We don't want these sub parts. It's just very difficult to handle. So just select everything, enable align objects and combine hierarchies, and you can just do one category, but 2 is the minimum, so we'll go with that. And if you just do that, you'll get one object because it will use the root object. It will count the amount of root objects. So delete this, and now you have a bunch of root objects. And now if we do this, we'll get a nice aligned, sanitized set of objects. Cool. Now at this phase, you would only have a few options here. If you try to export this as an FBX, all of them would have the same origin, which would be at this world origin. So you would have a prop here, which would have its origin all the way here, which is very horrible. And that's just how the way the exporter works. So internally, you could do this. You could manually just clear all the transforms and export this. And this would work. But now the problem is that every single asset pack you have will have to be like this. So we don't want that. We want it to be like laid out in a nice way in Blender. Another thing is if you have colliders and LODs, you will be out of luck. There are many ways to generate colliders, but I'll show you this simple method for now. So we just made a bunch of, let's make these ones a bit better. You don't need this add-on, you can just make the colliders yourself. I'm just doing it so it's a bit faster. But you would make your colliders and LODs in Blender, and you can export them now with the FBX Exporter, and I'll show you exactly how that works. Okay, and now let's make the LODs as well. So let me just select all the root objects and go back here and generate LODs. Like so, and I think I have to merge the meshes first to get better LODs. There we go, so 96 LODs. And now it's looking pretty good. So now you have your LODs and colliders, whatever method you used. And now you would select an object and go to the stats. And you could see that it's detected. So there's the base mesh, we have a collider and 3 LODs. And if we go to another object here, we can see that this one has 8 colliders and 3 LODs. So this visualizer already tells you everything you need to know. So you don't have to guess if your naming scheme is correct. All you have to do is make sure you're using the UCX naming scheme with the object name in the middle and a number at the end for colliders. And for the LODs, it's just the object name and LOD1 ascending. LOD 0 is the base object itself. That's why you don't start from 0 in this case. And you don't need this COACD add-on. It's just to make it faster. You can do this by hand, no problem. So once you are at this phase, you have your colliders and they're detected by the tool. You can see that everything is here. Then you're ready to export. So just ensure you have export selected individually enabled, and that's it. Like that's all you need to do. You don't even need this. This is for animation stuff. This is for the stats. And just make sure you select the correct engine. Even though we're using this naming scheme, it's used for all the engines, and that's because Unreal is the only engine that has a standard for this. Everything else is just, they don't care. You have to make your own standard when you use Unity, Godot, whatever. But the one thing that is common is that if you click one of these objects, you can see that it's one FBX file. So one FBX file will contain all the different colliders LODs, and it's up to you to set it up, set the LODs, set the colliders in Unity. And I will show it for Unity, but for Godot I won't, because it's the same method, it's just with the Unity, with the Godot components. But I'll show it for Unreal because there's only one way to do it for Unreal. So again, once you're at this phase where everything is detected, make sure that you have clear transforms enabled. If you don't do that, the origin will be here, or the origin will be here, and your object will be here. So you will have a mismatch. But if you do the clear transforms, your object will be here and your mesh, everything will be there. So they will sync. You will have no weird offset due to the world transformation. You can embed textures if you want. It will just recreate the materials in Unreal, but this is optional. I'll have it enabled for now. And everything else is just the same as you would have in the FBX Exporter. So if there's something strange here, it's most likely from here. So it's documented on the Blender side, not on the Ultitools side. But there are stuff like the target engine. I'll explain this stuff in the documentation explicitly. We do have animation stuff, and I'll show this in another video because it's very nuanced, so it does require its own video. But other than that, let's start. So select everything, and in this case we'll have 32 FBX files, and let's check this folder. So let's clear it. This was my previous attempt, just to make sure it worked, and let's wait for it to finish. So once you're at this phase, you can just export. And now if we go to Unreal, we will delete everything here. And let's import all of these. So when you do this, make sure that you have, if you embedded the textures, make sure that you are importing the materials. If you have LODs, make sure that you're importing the LODs, and if you have colliders, make sure you're importing the colliders. And that's it. Once you import everything, you'll get this as well. So sometimes, because I've imported this texture multiple times just to test it, it will ask you to override it. If this appears, you always do no, because otherwise the material will break. So that's edge case if you import multiple times. If you make a mistake and you have to redo, just be aware of that. It only supports basic material creation, so if your material has some crazy stuff, it might not work. But if you're just connecting images to the base color, roughness, metallic, normal, it will work just fine. So now we have our objects here. We can drop them. If we drop everything in one position, everything will be stacked like this. And that's because we have this clear transformation, and it's identical to just doing this and exporting. But the only difference is that now we support the LODs and colliders as well as the materials. Like some of the material handling has to be sanitized, In this case, it doesn't need to be, but if there was a mixed node with an ambient occlusion, the tool would still try to fix the material. So the material handling is a bit better. But you would probably not have this. If you're a level designer, you would probably just drop the assets like so. And just create your level like this. But as you see, it's very fast. Like to do this manually, to import all of these assets by hand would take a while. So already we are pretty far in it. But that's it. If we check like one of these meshes, we can see that indeed we have 4 LODs. The LOD visualization is broken in 5.7, but you can see the triangles actually change here. It might be due to nanite. I think it might be due to nanite. Let's... Not sure, but this broke recently. The visualization is broken, but you would see the different levels of LODs here. And the colliders are in player collision, and you can see that they are indeed using our custom colliders we just made. And this the same goes for every single asset here. So everything has 4 LODs and up to 8 colliders. Some have 1 because we use the single primitive collision generation. But this is pretty much everything you need to know about the static mesh import. It's pretty straightforward, and yeah, I'll show you the animation stuff now because that's a bit more nuanced. I was gonna do another video, but I'll just put it as a second part. I think that makes more sense. So to do this in Unity, you would just export the FBX. In this case, I just did it for this bed. And once you have it in your export folder, which is here, you just drag it to Unity and you will have something like this. Now this is the actual FBX file, and as you may notice, all of the colliders and LODs are still here. It's just that it's not automatic. So to turn this into a proper LOD bed, I'll show you. So you would have to make a mesh collider for each collision piece. It's ideal to make a script for this, but you can make this by hand as well. It's the Unity way. You kind of may have to make your own tools when you do development in Unity. Some people like it, some people prefer the automatic ways of Unreal, for example. But as long as you just have these collider components and the LOD group component, which has the LOD 0, 1, 2, 3, that's all you need to do. Like, it will automatically handle everything after this. Just make sure that all of the collision pieces are convex, as that is more performant, and it is as close 1-to-1 with what we have in Unreal. So now for the animation part of the FBX exporter. Here we have a character which has a bunch of animations. I'll show you interaction editor. A bunch of animations, everything you would need for this specific character. I'll use Animation Plus just to visualize this, but this is, you don't need this add-on. It just makes it easier for me to show what is happening. So a lot of animations, different kinds of death animations, locomotion in various directions. And a normal use case would be to, oh, I want this in Unreal. I want this in Unity, Godot, whatever. So the way you would do this is quite simple. You just select your mesh and your armature object, and then this is where the selection stats becomes more useful because it will tell you exactly what is happening. So we have a skinned rig and it detects it and it sees that there are 3 linked meshes. Now this is why this is important. Now if we don't include this linked meshes, if we have this disabled, it's not gonna detect the meshes. Now, you might want to do this if you just want to export the animations, which I'll show you. But you should have this enabled because you usually do want to export the animations with the rig initially. You might export more animations later without this. So the use case is there, and I'll show you the workflow I recommend. So for now, let's export this to Unreal. So let's see, is our folder clear? It is. And now we'll finally get to use the Armature Actions tab. So you will see your armature here, make sure it's selected, and then you do Reload Armature Actions. I recommend having one armature per blend file. Because Blender tends to show you everything, all of the actions here, and it can be a bit overwhelming if you have multiple characters in the same. It's just better. Just do one armature per blend file. But if you do refresh here, you should see all the animations here, and you can choose to enable animations you want and disable the ones you don't. In this case, I want all of these. So I'll keep everything enabled. And that's it. Now you're basically exporting the animations. So now you just select it and we can do export. And now if we go to Unreal, let's go to another folder and let's import the rig. Now when you import a rig, you should always, in this case, ensure you're importing the animations. And that's pretty much it for now. So we'll get all the animations and the skeleton. So if we click this, we'll see that we indeed have everything here. And for some people, this is usually enough. So you have everything you need. Now you can just do the blend trees for your animations and you'll be good to go. But now let's say we want to modify an animation. Or let's say we want to let's do the modification example because that is a common situation. So let's find death backwards and let's change the hand position at the end. Actually, let's just make sure the hand is always correct, like so. Something that we can easily see. Is it actually? It's a bit hard to see. Let's do this as well. So that is a modification that is easy to see. Now in this case, you shouldn't export again because we if we did this, we would import all of the animations again, and that usually causes issues later down in the pipeline. So you only want to change the animation we modified. So in this case, I usually do export selected individually. So now we get all the animations. And then I only usually want the animation itself. I don't need the rig anymore. And now we can just find the death backwards and quickly disable everything here. Let's make this a bit bigger so we see everything at once. And there we go. So now we just have one animation and we're good. So now if we go back to Unreal, let's go to the meerkat. And let's delete the animation here because we're replacing it. And let's import it. So it will automatically detect the rig, but make sure that it's the rig that the other animations are using. But otherwise, it should detect that it's only there is nothing here other than an animation. So now we have the death backwards. And we can see that indeed it's the same animation as we have here. So that's the workflow if you want to just edit one animation. Now, you might wonder, why couldn't we just export it, all of the animations? Like, isn't that just simpler? Well, it is, but the problem is that in Unreal at least, every single asset these are not FBX files anymore. Unreal converts these into a format called, it's not even here. I need to save everything. Unreal converts everything internally into a U asset. And a U asset is a unique binary file. And every time you make this U asset, it's different. Even though it might have identical animations, whatever, Unreal doesn't care. It just thinks it's different. And if you're working on a team, what that ends up looking like is that you just modified every single animation in the whole repository, which is bad. You don't want to modify all of the assets at once, only the ones you actually modify. So that's my explanation to why you should only export animations only and this. And I'll show you the basic animation for the export for Unity as well. So let's enable all of these animations. And that's it pretty much. Yeah, looks good. One file. Let's clear this folder. Let's go to Unity, and here's a old thing here, so I'll just cancel it for now. So the only thing you need to do is find your export file, just drag and drop. And that's it. If we go here, all of the animations are here, so there's nothing really special about this. And that's it. Same for Godot, you just drag and drop, and all of the animations are inside here. And that's pretty much it for the workflow. Like, that's the only two things you end up doing. You end up exporting animations and you end up replacing existing ones. This also works if you add new animations. You would just, it would appear here, make sure you reload if it doesn't, and you would just export that as a new animation. So this is a very versatile workflow. And the same goes for Unity and Godot. In that case, the only difference is that each file is an FBX file, so you would have the same issue there, because if you changed one animation, you would have to change all of the whole FBX file, which modify all the other animations. But enough of that. Let's go to the more advanced example, which is shape keys. So I haven't seen a workflow for this that is clear. So in this video, I'll be going through it. So this character actually uses shape key animations, and it's a lot more complicated than you would think, because each bone-driven action is associated with a unique blend shape. And the blend shape is just something on the mesh itself, like a property like this. And sometimes you are better off doing this instead of rigging it with a bone, like the blinking animations are usually done with this in a lot of games. But this is just to showcase that if you have this kind of advanced animation pipeline, you can bring it from Blender to Unreal, Unity, Godot, whatever. So let's start. So again, just you always should refresh this, because it's actually not tied to the actions in the blend file. But once you see this, you will probably have a lot of none here, but you should set it to a shape key of your choosing. So you can make shape key animations pretty simply. I'll show you. So to make a shape key animation, you have to go into the shape key editor. A lot of people don't know about this, but in here you make shape keys. And you can see that there are a lot of different shape keys. Keyframing them is done by keyframing this value. So you can really go crazy with this. There are a few videos on there on how to make shape key animations. I'm not going to cover that because that's more of a Blender thing, but I assume you know how to make shape key actions. So once you have these actions, in this case I have a lot of them, you associate each of these actions with a bone action, and bone actions are their own separate thing. And in this case I have a lot of them. And this animation plus add-on, you don't need it, but it just it has this implicit relationship with these shape key actions. So normally you would have to go here, and I'll show you. You would have to manually set the active shape key for each object that your armature uses, and I have 3 objects, so I would have to go into object mode, set the correct shape key action, then go to the action editor for the actual armature and make sure I have the correct. It's horrible. So that's why this animation plus tool exists, because this use case of having shape key actions and bone driven actions, they're supposed to work together, but it has the worst possible implementation in Blender than that you could imagine. So you just have to live with it. So I'll try to make this workflow as doable as possible. And I do recommend this add-on. It's just that it costs $10. It's just I can't avoid it. Doing this by hand is just too difficult. You don't need it, but it's just that you would be blind here. You would have to know exactly what shape key works with what action, which is it's a nightmare. And let's clean this up though. It shouldn't be this extreme. If you go into here, you can delete these unused shape keys. You'll see a lot less here, but you would see an action starting with O, and you would see these KE prefixed actions, and these are shape key actions, and that's how you can tell them apart. So you would associate every action with a appropriate shape key action, like this one. Let's see. I have to drag this up. Yeah, this one is associated with the draw shape key, which just increases the draw value here and does something with the eyes. This one fires, so it will set the bow string to the straight version. And all of these do different things. And they're all they're all meant to be played with a very specific animation. Some of them have none, and that's fine, because in this case the ref position has no association with anything. The dead one does. Not sure why. Oh yeah, because the eyes close when you die. So there are small things like that. But anyways, once you have associated each shape key action, which you made in object mode, with each bone animation, which you made in pose mode, then you're ready to use the advanced features of this add-on. So now if you go to the selection stats, now it will show you something else. It will tell you skinned, linked meshes, and everything seems fine, but the moment you try to disable this, it will detect it. It's like, oh, this animation has shape keys, and it will know that this animation has shape keys, so it will prevent you from doing this. And that's because you cannot export an FBX as a combined FBX anymore once you use these combined shape key actions. Once you have this situation where you have your actions with the correct shape keys, now you can finally just export this. So let's clear this for now, and you'll see something a bit different because we are exporting each individual action now. We get a lot of files, a lot of redundant files as well, but it just can't be helped. So if we go here, we have one action per animation. And now if we go to Unreal, we have to delete all of this. And then we import everything, and we import all of these FBX files. And now we just have to make sure that morph targets are imported, animations are target, and make sure this is disabled. We don't want only animations, but that should be everything. So we will get a skeleton for each animation, and that is, we can't avoid it. We just have to delete the extra skeletons, because we still want to only use a single skeleton. Because if we modify the skeleton in the future, we don't want to deal with 16. It's a waste of data, very wasteful. But in the import phase, we can't avoid this. So what is the solution? Well, you just make a folder called animation, and then we just filter for animations. Or, oh, I'm lazy. I'll just, the green ones are animations, so we always know exactly which ones we need. So that's all the animations. We move them into this animation folder. And now everything is good. So now we only need the ref pose. The other ones are just redundant. And we'll get this. We will lose a bunch of references, but don't worry, that's fine. And now we'll select all of the broken animations, and we will just let's see. We'll replace the skeleton. And choose the skeleton that's used by the one other animation. And that will fix all of the problems. And why did we go through this workflow? That's because if you look closely, now the actual shape key animations are embedded into each individual action. And we had a lot of actions with different shape key animations. If you use something like the Autorig Pro, they would only give you one. They would give you one action. And that's because Autorig Pro doesn't implement this key pairing thing. And this key pairing thing is the only reason why this works. So here we can see that we're pulling the bow correctly in this animation. And here we are releasing the bow. Everything is working as intended. Here we are holding the bow. Here we have a blink animation with the idle. It's amazing. Like I struggled with this workflow for a while because there was no other option available, and now there is. It's a bit hard to follow, I understand this, but this is the only way to do it properly, in air quotes, as I've found so far. So let's do it for Unity as well. You should enable Unity mode here because it will make the transforms a bit better. And you simply do the same thing as with Unreal. So you just export. And then you go to Unity. So let's disable. Let's put it in a folder. And all you have to do is export the FBX files. So we'll find this folder here. And let's go to the Explorer view. And then you can just copy this. to here, and now Unity will automatically detect it. So just like in Unreal, we have one FBX file per action. And you can play them here to see that they actually do work, like so. So again, you do the same thing, but in this case, you should export the individual animations. So it's good to have two folders here, and I'll just make a folder called animation. And then you just do this. And you can't just move it. You actually do have to copy paste. Otherwise it will copy the whole FBX file, so. And then you should delete it. Otherwise they will just accumulate. Again, it's recommended to do a script here. It's the Unity way. You would do the same in Godot as well. It's very similar to the Unity method. All of the correct animations are in each FBX file. You just have to extract them. And this copy paste actually creates a unique reference to it, a duplicate. So this is why we can just delete the original here. You only have to do this once, so it's not that bad to do it by hand. But it's a bit tedious. You have to do this more than a few times, you might want to make a script for it. And that's the last one. And we'll preserve the last one. So now you should make an animation controller and just put all of these here so that we can see this in real time. So let's put the animator here as well. And now we can finally drop that. And now if you look closely, you'll see that the actual mesh itself changes shading. And that's because the model itself has an import setting or blend shape calculation. And you don't want to calculate the blend shape normals. I usually do none. And that fixes the problem. So that's a small Unity edge case. But once you're done with this, you can just, with code, control all of these actions, and they have all of the information you need. The shape keyframes are at the top. And I explained this, but for Godot, it's the same. You just copy the actions and use them as is.